Hi guys, welcome back. Today we're going to be solving systems of equations graphically. So a system of equations is just a collection of two or more equations. For us, we're going to only focus on two equations, and our two equations will be linear. So this would be an example of a system. So in this red box is a system. It's just two different equations. And if you had to solve the system, you basically just have to find an x and y point that would work. So any x and y point that would work for both of these two lines, right? So in this case, you can solve a system of equations by finding an xy point that satisfies both equations. In this case, the solution is 2, 7 because the point satisfies both equations. So down here, you guys obviously know that this is an x point, and then this would be your y value. So if I plugged in my y value and my x value, 7 equals 2 plus 5. Yeah, it does. And then if you look at the other equation, we plugged in 2 for x and 7 for y. It would say 2 times 2 is 4, plus 3 times 7 is 21. 4 plus 21 is 25, so that works too. So that's how you would... So if you look down here at the graph, you'll see if we graphed both equations, they would intersect at 2, 7. So that is the solution. That is the xy point that works for both equations. So that would be your solution for the system. Let's look at this example. So for this example, if I had to graph this, I'm going to graph the first one in green. So it's going to start at -3, go up 2 over 1 to the right, up 2 over 1 to the right. I'm going to use a solid line to graph this because it's an equation. I'm going to graph the line in green too, so you guys can see it. And I'm going to graph the other line in blue. So y equals x plus 2. So that would be starting at 2 and goes up 1 over 1. And when I draw my line, I mean, you guys could already see what the intersection is going to be, but I just want to completely do this one. But you'll see that the intersection is going to be this point right here. So the point 5, 7 would be the solution. So the x value, y value. And if you wanted to, you could plug in the point 5, 7 to see that. So here, if I plugged in here, the y value is 7, the x value is 5, and we know 5 plus 2 is 7. And then up here, if I plugged in the y value of 7, it would be 7 equals, and then 2 times the x value of 5 minus 3. 2 times 5 is 10. 10 minus 3 is 7. So that's how you know that you would have graphed this correctly for both equations. Example, I'm going to graph the first one in green. So that's going to start at 7. Technically, I'm going up 3 over 1, but that would be off my graph. So I'm going to go in the opposite direction. I'm going to go down 3 over 1 to the left, down 3 over 1 to the left, and I'm just going to continue that line and fully extend it. And then I'm going to draw my line going through. And I'm going to graph the other equation, which is y equals x minus 3. So it's going to start here, and it goes up 1 over 1. So it'll be this line right here. So it goes in this direction, but it also goes in this direction, and this is where the intersection is going to be. The intersection is going to be down here. I'm just going to continue my line. So the intersection point is going to be -5, -8. And if you wanted to make sure that that actually works, what you would do is you can just plug into both of your equations. So plug in the x value, plug in the y value. So here the y value is -8. The x value is -5, so it'd be 3 times -5 plus 7. And then 3 times -5 is -15. -15 plus 7 is -8. And then if I check the other equation here, y value -8, x value -5, -5 minus 3 is -8, so that one works as well. For the next example, I just want to make sure that you are all familiar with graphing y equals 1, so that's why I'm going over this example. The first one would start at 4, and it goes down 1 over 2, so it would be this equation right here. And then for y equals 1, the slope is 0, so that's why there's no x value there. So it's going to be a horizontal line going across. So y equals 1 is actually going to look like this. So where y is 1, it's literally just a horizontal one where all the y values are 1. So if you look at our intersection point, the intersection point there would be 6, 1. And the last example that we're going to look at is y equals x plus 4 and y equals x minus 3. So for this example, I'm going to graph this one in red. So it's going to start at 4, and it goes up 1 over 1, up 1 over 1, up 1 over 1. So it'll be this line right here. And for the next one, I'm going to graph the points in blue, and that would start at -3, and it has the same slope. The slope is still 1, so it's going up 1 over 1, up 1 over 1. So when two lines have the same slope, they actually are parallel to each other. And if you know what the definition of parallel is, parallel means that they are never going to intersect, they're never going to meet. So if two lines are never going to meet, that means that they're not going to have a solution. This system would have no solution. So your answer, you would actually just write no solution. And that concludes our lesson. Thank you guys for listening. I hope you enjoyed.